Today we are going to finish our 4-day adventure with chapters 8.5 and 8.6 on exponential functions, and we are going to finish that by talking about a real-life application of exponential models, and that is investing money into an account that will pay you interest on your initial funds. Okay? Here we have our formula, which this is representing our growth model, because when you put money into a bank account, you're expecting it to get bigger, so we do want it to grow. In fact, it wouldn't make much sense to put it into an account where you are losing money. But this is our compound interest formula for investments, and we have y equals a times 1 plus r to the t. Looks very familiar to what we've been seeing the past 3 days, and it should. Here, a, again, is our initial amount. R is going to be our annual interest rate, and again, remember, when dealing with percents, when we do our operations in percents, it has to be in decimal or fraction form, but decimal is usually easier. And then T is the number of years the money is going to be invested. Okay, so for this example, it says you put $250 in a savings account that earns 4% annual interest compounded yearly. You don't make any withdrawals or deposits. How much will your investment be worth in 5 years? Okay, the first thing whenever we do a word problem is that we want to find our important information. Okay, so if we know we're going to be looking for an initial amount, we want to read through the problem and find the initial amount given. Here, our initial amount is $250. Okay, we also need to find our annual interest rate, which that is our percentage. Okay, if you remember from yesterday's lesson, writing things in percent form into decimal form is very simple. We just take the number without the percent sign and move the decimal spot 2 spots to the right, and that gives us 0.04. And then T, the number of years the money is invested, we are going to be checking out 5 years. Okay, so now we just plug and chug. So we're going to have y equals our initial amount, $250, times 1 plus our interest rate, written as a decimal, 0.04, to the t power, number of years money is invested, which is going to be 5. Using our order of operations, we want to do parentheses first. So we're going to have 250 times 1.04 to the 5th power. From there, we are going to take our exponent, so 1.04 to the 5th power, which is about, oops, that's a 0, about 1.2167, and that will give us approximately $304. Okay, so if you just put $250 into an account, you don't add anything extra into an account that gives you 4% interest, after 5 years you will have earned yourself $54 for a total of $304 in your account. Okay? But what happens if you have an account that, say, compounds your interest more than just once a year, more than just yearly? Say you have something yearly, monthly, or quarterly. Okay, that is what our general interest formula is going to tell you. Okay, so we have our total amount that's going to equal P times 1 plus R divided by N to the N times T power. Okay, this is our same formula except that we're introducing one new variable, which is this N. Okay, P is the same thing as our A from the last formula, it's just a different letter representing it. So we have P, that's our initial amount, same thing. Then we have 1 plus, here the difference is this N factor. We have our annual rate still, but it's divided by the number of times that we're going to compound it per year. Okay, so if you're compounding yearly, that value is 1, which is why in our last formula it was compounding yearly. We didn't need that N, because R divided by 1 is R, and T times 1 is T. If we're compounding monthly, how many months do you have in a year? You have 12. So your value of N is going to be 12. If you're compounding quarterly, how many quarters are in one whole? 4. So you'd be compounding 4 times or once every 3 months. And if you're compounding daily, your value of n is going to be 365, unless, of course, it is a leap year, in which case it will be 366. Okay? So we're going to have r divided by n in our parentheses, and then we're going to take it to the n times t power. Okay? You don't have to worry about making that decision on your own. In the problem, it will tell you what it will be compounded by. So the biggest thing is just remembering this formula, and then it will also be using your order of operations to make the computation. Okay? So, here we have our formula. Let's read this problem. You deposit $1,000 in an account that pays 3% annual interest. Find the balance after 8 years if the interest is compounded A, monthly, B, quarterly, and C, daily. Okay, so we're going to do 3 different calculations. So here, if we're looking for our important information, this $1,000 is our P. This 3% is our rate, which written as a decimal is 0.03. And then 8 is going to be our T. Okay, so if we're compounding monthly, we are going to have, not Y, we're going to have A equals P, our initial amount, 1,000, times 1 plus our R, which is 0.03, divided by our N. If we're compounding monthly, that means our N is going to be 12. So we're going to have 0.03 divided by 12 to the 12 times N times T, 12 times 8 power. Okay? So simplifying that, we're going to have 1,000 order of operations. We want to do our parentheses first. So we're going to have 0.03 divided by 12, which is 1 plus 0.0025 to the 96th power. Okay, simplify inside our parentheses, we have 1,000 times 1.0025 to the 96th power. Next on our order of operations is exponents. So remember, this exponent belongs only to that that's inside the parentheses. It doesn't belong to the 1,000. So if we take 1.0025 to the 96th power, that is going to give us approximately 1,000 times 1.27087, which is going to give us about $1,270.87. Okay, that's if we're compounding once every month. So when you say something compounded monthly, that means that in the first month we had $1,000. So we take 3% of that and add the 3% of that to that initial total. Then after 1 month we take that new total and take 3% of that new total and then add that to the fund that's already in the account, and you keep doing that every month. That's what it means compounded monthly. Okay? If we're compounding quarterly, that means that we are going to compound this 4 times within the year. So that means our N is going to be 4. Okay? Our P, our R, and our T still remain the same. So we're going to have A equals 1,000 times 1 plus R divided by N, 0.03 divided by 4, to the 4 times 8 power. Okay, so if we simplify that, we have 1,000 times 1 plus 0.0075 to the 32nd power. Okay, we add what's in our parentheses. So we have 1,000 times 1.0075 to the 32nd power. Now we took care of our parentheses, now we're going to take care of our exponents. So we have 1.0075 to the 32nd power, which is about 1,000 times 1.27011, which is going to give us times 1,000, $1,270.11. We probably could have done that in our heads, couldn't we have? 1, 2, 3. And over here, 1, 2, 3. Yes. Could have happened. I'm just not thinking, apparently. Alright. And last but not least, daily. If we're compounding daily, that means that we have our n is 365. We're going to use 365 just because it's more general. Even though this year is a leap year, we will use 365. Just because more often than not, it's 365. Okay, so we're going to have A equals our P, which is 1,000, times 1 plus our rate, 0.03, divided by our N, 365, to the 365 times 8 power. Woo! So we're going to have 3,000 times 1 plus 0.03 divided by 365. Oh dear goodness. Okay. We're going to have 0.00008219. Yep. Okay, and then we're going to have 365 times 8, and this is going to be to the 2,920th power. Okay? Alright, so we're going to have 1,000 times 1.00008219 to the 2,920th power. Using our exponents, we take 1.00008219 to the 2,920th power, which is going to give us approximately 1.27123, which will give us $1,271.23. Okay? So, if we're compounding things, the more often we compound it, the more money we make. If you can see daily, we make a little bit more than monthly, and we make a little bit more than quarterly. Not a lot, but a smidgen more. Okay? And that is our last day for exponential functions. I hope you enjoyed our 4-day adventure. See you in class.